In this video, let us try to solve these two unique problems where we have to apply the understanding of arithmetic progression in the second one, and the first one is a unique problem where we are equating three trigonometric functions. So let's try the first one now. So in the first one, the information given to us is a sin x is equal to b sin of x plus 2 pi by 3 is equal to c sin of x plus 4 pi by 3. So we have three components here which are equal to each other. So using this information, we have to prove that AB plus BC plus CA is equal to 0. So this is a unique problem. Let's solve this. So we have a sin x plus b sin of x plus 2 pi by 3. This is equal to c sin of x plus 4 pi by 3. So basically when we equate something called a is equal to b is equal to c, they have some actual value when we are equating them to each other. So what we'll do is, let's consider this equal to d. So basically all these three terms are equal to d. So we can write this as a sin x is equal to d. So sin x is equal to d by a. Then second part, we can write this as b sin of x plus 2 pi by 3 is equal to d. So sin of x plus 2 pi by 3 is equal to d by b. And the third one we can write as c sin of x plus 4 pi by 3, this is equal to d. So sin of x plus 4 pi by 3 is equal to d by c. Okay, now what we'll do is, let's add all these three. So what we'll do is d by a plus d by b plus d by c is equal to sin x plus sin of x plus 2 pi by 3 plus x plus 4 pi by 3. Now we have something to work with. This is of the format maybe sin C plus sin D plus sin E. So we can combine two terms together and apply the formula of converting a sum to a product. So let's group sin x and sin of x plus 4 pi by 3 and see what we can achieve here. So this is sin C plus sin D. So the formula is 2 sin C plus D by 2 multiplied by cos of C minus D by 2. So let's apply that. It is sin of x plus 4 pi by 3 and cos of x minus 4 pi by 3. Correct? This is by 2, this is divided by 2. Then plus sin of x plus 2 pi by 3. That is the remaining term. So let's simplify this. What we would get is 2 sin x plus 2 pi by 3 and cos of x's gets cancelled, so we'll have minus 2 pi by 3 plus sin of x plus 2 pi by 3. Now cos of minus x here is cos x, so we can just change it to plus 2 pi by 3. It does not matter. Okay, now this will be 2 times sin of x plus 2 pi by 3 multiplied by cos of 2 pi by 3. So cos 120 is minus 1 by 2 plus sin of x plus 2 pi by 3. So we can cancel the 2 here. So this will be minus sin of x plus 2 pi by 3 plus sin of x plus 2 pi by 3. So we can cancel this 2 because there is a negative sign here. So the answer we would get is d by a plus d by b plus d by c. This is equal to 0. Now let's solve for the common denominator. So basically what this is d times 1 by a plus 1 by b plus 1 by c is equal to 0. We can cancel the d because if we divide both the sides by d, we can cancel it out. Now let's solve for the common denominator. So the common denominator is abc, and the first value would be bc plus ac plus ab. This is equal to 0. We can cancel abc. So final answer is ab plus bc plus ca is equal to 0. So this is how we can solve the first question. Let's try the second one. In the second question, the information given to us is sine of y plus z minus x and sine of z plus x minus y and sine of x plus y minus z. These three are an arithmetic progression. So using this information, we have to prove that tan x, tan y and tan z, these three are also in arithmetic progression. Now let's understand the basic of arithmetic progression. So let's consider three numbers 10, 20 and 30. So if we compare this, each number when it increments, it is incrementing by a constant value of 10. So 10 plus 10 is 20 and 20 plus 10 is 30. So this is called an arithmetic progression series. So if I consider 10 to be A, 20 to be B and 30 to be C, we can infer that 2 times B is equal to C plus A. That means 2 times B is 2 times 20, 40 is equal to 10 plus 30. Also, in arithmetic progression, B minus A is equal to C minus B. So B minus A is 20 minus 10, which is 10, is equal to 30 minus 20, which is also equal to 10. So these two are the important things we have to understand in arithmetic progression. Now let's apply this in the question. So let's consider the first term as A, the second term as B, and the third term as C. So we will apply B minus A is equal to C minus B to this question. Let's do that now. So B minus A will be sine of z plus x minus y minus sine of y plus z minus x is equal to C minus B is sine of x plus y minus z minus sine of z plus x minus y. So here we have something to work with now. This is of the format sin C minus sin D, which can be changed to sine of C minus D by 2 and cos of C plus D by 2. So let's apply this formula on both the sides. So the left hand side will be 2 cos C plus D by 2. So that will be cos of z plus x minus y plus y plus z minus x, this divided by 2 times sin C minus D by 2, that will be z plus x minus y minus z plus x, this divided by 2. This is our left hand side. This will be equal to, let's apply that on the right hand side as well. This will be equal to 2 cos C plus D by 2, which is x plus y minus z plus x minus y, whole thing divided by 2, and sin C minus D by 2. That will be x plus y minus z minus x plus y, this thing divided by 2. Now let's see what can be cancelled out here. We can cancel 2 then in the first part we can cancel x and minus y and y. Now in the second part we can cancel only z. Okay. Now on the right hand side we can cancel y and minus y and minus z and z, and in the last term we can only cancel out x. So after simplification we would have cos z multiplied by sine of 2x minus 2y divided by 2, that will be x minus y. This is the left hand side, and this is equal to, on the right hand side we will have cos of 2x plus 2, that is cos x, multiplied by sine of 2y minus 2z by 2, which is y minus z. Now this is of the format sine of a minus b on both sides. Let's apply that formula. So we have, sorry about that, sin x cos y minus cos x sin y, this multiplied by cos z is equal to sin y cos z minus cos y sin z, this multiplied by cos x. So let's simplify this. We have sin x cos y cos z minus cos x sin y cos z is equal to, on the right hand side it is cos x sin y cos z minus cos x cos y sin z. Now let's see how we can solve this. Let's identify common terms. So we have cos x sin y cos z and cos x sin y cos z on both the sides, but one is negative and one is positive, so we can rearrange this equation. So this will be sin x cos y cos z, then I'm moving this last part to the other side, which will be plus cos x cos y sin z is equal to, now I am moving this to the other side, so we have 2 times cos x sin y cos z. Now in the question the requirement is that we have to prove tan x, tan y, tan z are in arithmetic progression. So to change sine and cos combination to tan, what we can do is we can divide both the sides of this equation by cos x cos y cos z. So let's divide both the sides. So the first term we can cancel out cos y cos z, and we'll have sin x by cos x plus, and in the second term we can cancel out cos x and cos y, so we'll have sin z by cos z. This will be equal to 2 times, here we can cancel out cos x and cos z, we'll have 2 times sin y by cos y. So this is nothing but tan x plus tan z is equal to 2 times tan y. Now let's go back to the understanding that we had about arithmetic progression. So in arithmetic progression we have, if a, b, c are in arithmetic progression, then 2b is equal to c plus a. So if we consider x, y and z are in AP, then 2y is equal to x plus z. Similarly, if tan x, tan y and tan z are in arithmetic progression, then 2 times tan y is equal to tan x plus tan z. So that is what we actually got here. So 2 tan y is equal to tan x plus tan z. That's why tan x, tan y and tan z are also in arithmetic progression. So this is how we can apply the logic of arithmetic progression in trigonometric functions. So this is one of the unique problems we have solved. If you like these videos, please share it with your friends so that it is useful to them too. Thank you so much for watching till the end. I'll see you in the next video.